Hello everyone. Today we are embarking on a journey to one of the most bizarre and misunderstood worlds in our entire solar system. Venus, our nearest planetary neighbor, often called Earth's twin, yet hiding a cosmic secret. So strange, it rewrites everything we know about planetary time. This is the slowest spinning planet, where a single day lasts longer than a full year. For billions of years, Venus has danced around the sun, at a pace that defies all our earthly intuition. And today, we're going to unpack every layer of this mind-bending mystery, from ancient stargazers' first observations to cutting-edge NASA missions that finally cracked its slow-spinning code. Let's start with the numbers that make Venus truly one of a kind. On Earth, we take our 24-hour day and 365-day year for granted. It has a rhythm that shapes our lives, our calendars, and our very sense of time. But step onto Venus, and that rhythm shatters completely. According to precise measurements from NASA's radar, astronomy, and orbiting probes, Venus takes 243 Earth days to complete one full rotation on its axis. This is its sidereal day, the true measure of how long it takes to spin once, relative to the stars. Now, compare that to its trip around the Sun. Venus zips through its orbit in just 224.7 Earth days its orbital year. Let that sink in for a moment. The planet spins so slowly that by the time it finishes one full day, it has already circled the Sun once and is nearly 18 days into its next year. No other planet in the solar system comes close to this backwards relationship between day and year. Jupiter, the fastest spinner, rotates once every 10 hours. Mercury, the innermost planet, spins every 58 Earth days but takes 88 days to orbit the Sunday. Even Mars, our other close neighbor, has a day just 37 minutes longer than Earth's. Venus stands alone as the ultimate slowpoke, a world where time itself moves at a glacial, almost unthinkable pace. To make this even more surreal, Venus doesn't just spin slowly, it spins backwards. This is called retrograde rotation, and it means that if you stood on Venus's surface, you would watch the sun rise in the west and set in the east, the exact opposite of what we see on Earth. From a vantage point above the solar system's north pole, every planet orbits the sun counterclockwise, and nearly all spin counterclockwise too, except Venus and Uranus. Venus's axial tilt is 177.36 degrees, almost completely flipped upside down, which locks it into this reverse spin. For decades, scientists were baffled by this double oddity, extreme slowness, and backward motion. How could a planet form and evolve to end up like this? The story of how we uncovered Venus's rotation secret is as epic as the planet itself. For thousands of years, humans gazed at Venus as the brightest object in our night sky. After the moon, our ancestors named it the morning star and evening star, thinking they were two separate celestial bodies. Ancient Babylonians tracked its movement as early as 3000 BCE, and Greek astronomers later realized it was a single planet. But no one could figure out how fast it spun, because Venus is shrouded in a thick, opaque blanket of sulfuric acid clouds that completely hide its surface from optical telescopes. For centuries, astronomers guessed at its rotation rate, with early estimates ranging from a 24-hour day to a tidally locked world that always showed one face to the sun, like the moon does to Earth. All those guesses were wrong, and it wasn't until the dawn of the space age and radar technology that we finally got the truth. In the 1960s, NASA and other space agencies began bouncing radio waves off Venus's surface. These waves could pierce the dense clouds and bounce back, carrying clues about the planet's rotation, speed, and direction. In 1962, NASA's Mariner 2 became the first successful interplanetary probe, flying past Venus and confirming early radar data. Venus spins extremely slowly, and it spins backward. This was a seismic discovery in planetary science, one that forced astronomers to completely rethink their models of how planets form and rotate. Later missions would refine these numbers. The Magellan probe, launched by NASA in 1990, used synthetic aperture radar to map 98% of Venus's surface with unprecedented detail, and it confirmed the exact rotation period: 243.02 Earth days for a full spin, 224.7 days for a full orbit. The European Space Agency's Venus Express and Japan's Akatsuki orbiter added even more precision, finding that Venus's rotation speed varies by up to 20 minutes due to its chaotic atmosphere, a wild detail that makes this slow world even more fascinating. Now, let's dive into the science behind why Venus spins so slowly and backward. There are two leading theories, both shaped by the violent, chaotic early days of our solar system. when planets were built by endless collisions and gravitational tugs. The first and most dramatic theory is the giant impact hypothesis. Billions of years ago, when the solar system was still a swirling disk of gas and rock, Proto-Venus was likely struck by a massive protoplanet 1, as big as Earth, or even larger. This catastrophic collision wouldn't just leave a crater. It would wallop the planet so hard that it flipped its axis upside down and slammed its rotation to a near halt. This is similar to the leading theory for how Earth got its moon, but on a scale that would alter a planet's entire rotational destiny. Computer simulations show that such an impact could easily reverse a planet's spin and slow it to the crawl we see today. The second theory focuses on tidal forces and atmospheric drag, a slower, more gradual process that shaped Venus over billions of years. The Sun's powerful gravity exerts a huge tidal pull on Venus, just as the Moon pulls on Earth oceans. But Venus has no moon to stabilize it, and its atmosphere is unlike anything else in the solar system. 96.5% carbon dioxide, 100 times denser than Earth's atmosphere, with super-rotating winds that blast around the planet at 350 kilometers per hour, 60 times faster than the planet's surface spins. This thick atmosphere creates massive tidal bulges that the Sun's gravity tugs on relentlessly, acting like a cosmic brake that slowed Venus's spin over billions of years. Over time, this braking effect became so strong that it not only slowed the planet to a crawl, but also flipped its rotation direction entirely. Most scientists today believe a combination of these two factors, an ancient giant impact and billions of years of solar tidal drag, created Venus's one-of-a-kind rotation. This slow spin has profound effects on every aspect of Venus's environment, making it a hellish world that couldn't be more different from Earth, despite being nearly the same size and mass. Because Venus spins so slowly, it has almost no magnetic field, unlike Earth, whose rapid spin creates a protective magnetosphere that shields us from solar wind. Venus's lack of a magnetic field lets solar wind strip away its upper atmosphere over time, and its thick carbon dioxide blanket triggers a runaway greenhouse effect that heats the surface to a blistering 462 degrees Celsius, hot enough to melt lead and tin, and hotter than Mercury, even though Mercury is much closer to the Sunday. The slow rotation also means Venus has no seasons. Its axial tilt is just 3 degrees, so sunlight hits every part of the planet almost evenly year-round. There are no warm summers or cold winters, no changing foliage or shifting weather patterns, just a constant crushing, scorching heat that never lets up. Day and night barely matter on Venus because the thick atmosphere traps heat so efficiently that the temperature is the same on the dayside, nightside, poles, and equator. A single sunrise on Venus takes hours to complete, and the time between one sunrise and the next, its solar day, is 116.7 Earth days. Still, staggeringly long, but shorter than its sidereal day, because of its backward spin and orbital motion. This means that in one Venus year, the sun rises and sets only about twice. Imagine living in a world where a single stretch of daylight lasts nearly 4 Earth months, followed by 4 months of darkness, yet the temperature never drops. It is a world where time is unrecognizable, where the very concepts of day and year are flipped on their heads. Exploring Venus's slow rotation also teaches us invaluable lessons about planetary science and our place in the cosmos. It shows us that planets are not just static balls of rock and gas. They are dynamic, evolving worlds, shaped by cataclysmic impacts, gravitational interactions, and atmospheric processes that can completely alter their behavior over billions of years. Venus is a cautionary tale for Earth. It demonstrates how a runaway greenhouse effect can turn a habitable-looking world into a scorched wasteland, and it reminds us that even small changes in a planet's rotation or atmosphere can have cascading, irreversible effects. NASA's upcoming missions, like Da Vinci Plus and Veritas, will return to Venus to study its atmosphere, surface, and interior in even greater detail, hoping to unlock more secrets about its slow spin, its ancient past, and why it evolved so differently from Earth. These missions will build on the legacy of Mariner 2, Magellan, Venus Express, and Akatsuki, continuing humanity's quest to understand our cosmic neighbors. When we look up at Venus in the evening sky, glowing bright and beautiful, we re not just seeing a pretty point of light. We re-seeing a world that defies the laws of time as we know them, a planet that takes longer to spin once than to circle its star. It is a testament to the infinite variety and wonder of our universe, a reminder that there are still countless mysteries waiting to be uncovered, beyond our home planet. Every time we study a planet like Venus, we expand our understanding of physics, astronomy, and the fragile balance that makes life on Earth possible. We learn that the universe is full of extremes of worlds that challenge our assumptions, and of stories that are more epic and awe-inspiring than any fiction we could imagine. Venus, the slowest spinning planet, the world, where a day outlasts a year, is one of the greatest stories in our solar system, a story of chaos, evolution, and the unyielding laws of physics that shape every corner of the cosmos. Please like, comment, share, and subscribe to the channel